You have built an AI agent. It works on your laptop. You deploy it. And then, did it answer correctly? Did it hallucinate? Did the tool call timeout? Did it burn through your entire token budget in a loop? You have absolutely no idea because right now you're flying blind. Here is the reality of running AI agents in production today. Unlike traditional APIs where you have HTTP status codes, response times, error rates, agents are black boxes. Think about what happens inside a single agent run. The LLM gets called maybe multiple times, tool gets invoked, web searches, database queries, API calls. The agent reasons, sometimes in loops. The agent responds, sometimes with hallucinated content. If any of these steps fail, you will find out when the user complains. Or worse, you don't find out at all. Let me give you 3 real scenarios that happens every day. Your weather API start returning 4 to 9 rate limits at 2 a.m. Your agent start telling users, I cannot access weather data. You find out Monday morning from a Slack messages. Now it's a 48 hours of broken responses. Second scenario, the LLM gets stuck in a reasoning loop. It calls the same tool 15 times in a row, burn through 500k tokens, and your OpenAI bill spike by $200 in a single night. No alert, no notification, just the invoice. The third scenario, your retrieval quality degrades silently. Your vector database returns irrelevant documents. The agent starts hallucinating answers that looks correct but are factually wrong. Your users lose trust. You don't even know it's happening because the agent returns 200 OK every time. Now, what is the common thread between all these 3 scenarios? There is zero observability, zero telemetry, and zero alerts. So what's the fix? The same thing we have been doing in backend engineering for a decade, but adapted for agents. It's called OpenTelemetry. And I built a system that makes it dead simple to add to any LangChain or LangGraph agent. What is observability for agent? Observability means 3 things: metrics, traces, and logs. Metrics tells you the aggregates. How many tool calls per minute? What's your P95 latency? What's your failure rate? These powers dashboards and alerts. Traces tell you the story of a single request. The LLM was called, it decided to use the weather tool. The tool took 340 milliseconds, and then the LLM formatted the response. Full causal chain with timing. Logs tell you the detail, the exact error message, the stack trace, the raw API response that caused the failure. You need all 3. Metrics tell you something is wrong. Traces tell you what went wrong, and logs tell you why. Here's how AgentPulse works. Your agent code imports AgentPulse SDK. The SDK has a callback handler that hooks into LangChain automatically. Every LLM call, every tool invocation, every chain execution get captured as OpenTelemetry spans and metrics. Zero code changes to your agent logic. Those signals flow to OpenTelemetry collector, that's a central router. It splits the data 3 ways. Traces go to Tempo, so you can search and drill into individual runs. Metrics go to Prometheus, so you can aggregate alert and dashboard. Logs go to Loki, so you can search exact error message. And Grafana sits on the top as a single pane of glass, showing you dashboards, letting you jump from a metric spike straight into the trace that caused it and then into the logs that explains it. All of this run in Docker. One Docker compose up and you have an enterprise-grade observability for your agents. And it is not just dashboards. AgentPulse comes with pre-built alert rules. Agent failure rate above 10%, that's a critical alert. Tool failing more than 30% of the time, it's a warning. A reasoning loop detected, immediate critical alert. Token spending 2x more than yesterday, then it's a cost anomaly warning. So you go from finding out Monday morning to getting paged in 2 minutes. That's the difference. Enough talking about it. Now let me show you the actual code in the live demo. First, let's spin up observability stack using one command. So we just need docker compose command and 6 containers. That is OpenTelemetry collector, Prometheus, Tempo, Loki, Alert Manager, and Grafana, all pre-configured, all wired together. We'll wait for it to be healthy. When everything is healthy and Grafana is set to be running at localhost 3000 port. Now, let's run the agent. To run the agent, I will be executing agents with tools Python file. This is the React agent with two tools, get weather and get forecast. It uses GPT-4o with GitHub Models API. Watch what happens. There it is. The agent called get weather for Seattle, got current condition clear 22 degrees, then called get forecast, got a 3-day outlook. Now look at the bottom. AgentPulse health, connected, spans exported. The telemetry just flowed through the entire pipeline. Review. Now here's the payoff. Here is the Grafana, and I'm going to agent overview dashboard. Look at these panels. They are updated in real time. So we can see there are two total tool calls, get weather and get forecast. Total error rate is 0% because both of them succeeded. Tool P95 latency shows how each tool took. Tool call by name bar charts break down which tools were used. Tool calls over time shows the rate. Tool latency over time shows P50, P95 and P99 percentiles. Now let me show you the traces. In Tempo, I can search traces for the service. Weather agent. Here's a trace. See the waterfall. The root span is a chain. Under it, you can see the first LLM call. The agent think which tool it needs to use. So there is a tool call, get weather, which took around 340 milliseconds. There is a second LLM calls, decide to get forecast. So there is a tool call for get forecast. And then there is a final LLM call, which formats the response. So every single step is visible. If any of these failed, I see it immediately, red span, error message, and exact duration. Now let me show you what happens when things go wrong. Let me simulate a network failure. If a weather API starts timing out, you would see tool error rate jumps from 0% to 100%. The agent tool failure spike alert fires within 2 minutes. Agent manager send a webhook to your notification system. In Tempo, the trace shows you the red error span on the tool call. In Loki, you see the exact timeout error message from something feels wrong to here's exactly what broke and when in under 2 minutes. That's the power of telemetry. Now let's understand the code. So here we have the agent with tool Python file. Here's the magic part. Adding observability to your agent is just 3 lines. In first line, we import the SDK. So here we are importing AgentPulse and AgentPulse callback handler. In line 2, we configure it, the service name, the collector endpoints. That's it. In line 3, we create a callback handler and passes it to your LLM. So here we are creating this handler and then we are passing this handler to the LLM. That's it. No decorating every function, no manual span creation, no metric boilerplate. The callback handler automatically intercept every LLM call, tool call, chain, and retrieval operation. Now let me show you what happens under the hood. The AgentPulse callback handler extends LangChain base callback handler. It has method for every lifecycle event. So if you see on tool start, when a tool begins executing, it creates OpenTelemetry span, records the tool name, input length, and starts a timer. On tool end, when the tool finishes, it calculates the duration, sets the output length as an attribute, mark the span as OK, and crucially records the tool call metric. That one line is what feeds the Prometheus counter and histogram that powers those dashboard panels we just saw. And on tool error, when a tool fails, same pattern but mark the span as error, records the exception, and run the failure classifier to auto-categorize what went wrong. So here is the metrics layer. The metrics module define all the OTel instruments, counters for things that only goes up, like tool calls, token consumed, failures. There are histograms for distributions, latency, step counts, retrieval scores. Each has a clear name following semantic convention. Agent.tools.calls, agent.llm.tokens. These names maps directly to Prometheus stores and what the Grafana dashboards query. Now let's take a look at the tools. The tools themselves are plain LangChain tools. The @tool decorator are docstring the LLM reads and a normal Python code. No observability code inside the tool. The callback handler captures everything externally. Your tool code stays clean. Now let's understand the last piece, which is the resilient exporter. If your OTel collector goes down, the SDK doesn't crash your agent. It has a circuit breaker, and when the collector is unreachable, spans get queued in memory. And when it comes back, they flush automatically. Your agent keeps running. Observability is never in the critical path. So to recap, the pain point where agents are black boxes, you cannot see when they break, why they break, and how much they are costing you. The solution for this? Open telemetry based observabilities. Traces, matrices, logs, automatically captured via callback handler. The implementation, it's just 3 lines of code in your agent, 1 Docker compose command for the infrastructure, and you get the production ready dashboards and alerting out of the box. This code is present in my GitHub. You can fork it and start using it. Thanks for watching this video.